Lindsay Jacobson, and this is The Evolution of Our Universe. The current theory for how the universe formed is the Big Bang Theory, which states that matter used to be very small and dense. They believe that all the matter in the universe was compacted into one extremely dense little ball that eventually exploded and expanded outward, this being the Big Bang. We have been able to prove this part of the Big Bang Theory to be true. We believe the explosion to be true because if an explosion of this magnitude were to take place, it would have left behind heat in the form of radiation. We measured the temperature of the universe to try and prove this using microwaves, and in fact, the universe was found to be 3 degrees above absolute zero, which is due to the leftover radiation from the Big Bang. This test was called the cosmic microwave background. The Big Bang Theory also states that the farther away galaxies are, the faster they will be moving. This is also known as Hubble law. To prove Hubble law, the Hubble telescope took an image of the farthest galaxies it could see called the Hubble Deep Field. They then calculated the approximate distances of the galaxies as well as the approximate speeds of the galaxies. They did this by looking at the colors of the galaxies. The Doppler effect states that if something is traveling away from you, then it will have a longer wavelength. Since purple has a short wavelength and red has a long wavelength, the faster things are moving away, the redder they will look. Because the galaxies we calculated to be farthest away from us were the reddest, it confirmed Hubble law and another part of the Big Bang Theory. Although all of this evidence proves the Big Bang to be true, there is one controversy. The Big Bang finally states that the universe should be spherical. However, there was an experiment done to prove if the universe was round. Some experimental physicists shot a laser into space to see if it would curve, but it never did, suggesting that the universe is flat. This would in fact disprove the Big Bang Theory. Many people claim that these results were invalid, but we don't know for sure yet. The next thing that formed in the universe were stars, but to understand how these formed, we must first understand the 3 types of explosions. The first and weakest explosion is combustion. It is when 2 atoms combine in the presence of oxygen to form a molecule. The second explosion is of medium strength and is called nuclear fission. It is when a very large atom splits in 2 to create 2 new smaller atoms. The last and most powerful explosion is nuclear fusion. It is when a very small atom fuses with another to form a bigger atom. Essentially, stars form through nuclear fusion. After the Big Bang, the universe was filled with burning hot hydrogen gas. The gas began to gather due to gravity. Then the hydrogen atoms began fusing together to form helium. Later, the helium would fuse together to form beryllium, and so on up to neon, the largest atom that can be made through fusion in stars. This is how stars are formed. While stars are alive, they remain at hydrostatic equilibrium, which states that the force of gravity pushing in on the star is balanced by the fusion explosion outward from the star. This gives the star a constant shape and size. After many stars in our universe had formed through fusion, we began to see galaxies develop. Stars began to gather closer in clusters due to their gravitational pull. This is how an irregular galaxy forms. After quite some time, a very large star in the galaxy would die, forming a black hole. Since the black hole will have such a great gravitational pull, the stars nearest to the black hole will get sucked into it, but the other stars in the galaxy will just be drawn closer to the black hole. As the stars orbit around the black hole, the galaxy then appears to have arms, making it a spiral galaxy. Because of the black hole's gravitational pull, our solar system is not still in our galaxy, but instead orbiting the black hole. Next, after a smaller star dies, it forms a nova, where the atoms fuse to form some of the larger elements. These elements begin as a cloud of dust but condense to form a planetesimal. These planetesimals collided with each other to form planets. When the planetesimal Theia hit Earth, it knocked us on our axis and broke off a chunk of Earth that became our moon. Ever since Theia hit us, Earth has been wobbling on its axis once every 26,000 years. This is called nutation. This leads to precession, which is the concept that the stars look like they are moving around us based on the movement of our axis. To explain our planetary orbit in simple terms, I am going to use the laws of Kepler. Kepler's first law states that planets travel in an elliptical orbit, with the star being one focus point and the barycenter being the other. The barycenter is the solar system center of gravity, which everything including the sun orbits. This means Earth's distance from the sun actually varies. Kepler's second law states that the closer the planet is to the sun, the faster it will travel because of gravity. This means that sometimes Earth moves faster than other times. Kepler's third law states that the farther the planet is from the star it orbits, the longer it will take to complete one orbit. This means that the farther out planets in our solar system will take longer to orbit the sun than we will. Earth's orbit is also what causes seasons. Because we are at a tilt, the angle of the Earth towards the sun changes throughout the year. When the angle of the sun to the Earth is smaller, it is warmer, making the season summer. When the angle of the sun towards the Earth is larger, it is colder, making the season winter. Since Earth is a 23.5 degree angle, when the northern hemisphere is pointing towards the southern hemisphere is pointing away from the sun, and vice versa, making the seasons in each opposite. In addition to the sun affecting our weather, it is also the source of all of our energy. The energy from the sun travels to the Earth as radiation. Plants capture this radiation and use it to transform carbon dioxide and water into glucose and oxygen through photosynthesis. When the energy is in sugar form, it is a form of chemical energy. Plants store this energy for future use, but humans can eat the plants and use the energy. When a large group of plants die, they are buried by dirt. After many years of the plants being heated from the core and pressurized by the dirt, the plants turn into fossil fuels, either coal, oil, or natural gas, which we can burn to use as electrical energy.